Good afternoon, welcome to my laboratory. This is part 4C of the continuing saga of the Ainslie Q2 oscillations. What you're looking at there, of course, is my trusty rusty TriField meter, and I have it set right now to the radio microwave range, right there. So that will be the bottom scale, and that's calibrated in milliwatts per square centimeter into the front of the box. Okay, and over here I have the Ainslie, or rather the single MOSFET oscillator that I'm using to explore the oscillations, the reason for them, and their effects. This is the same circuit diagram as in 4B, or rather 4A, because I'm using, or just 4, because I'm using the function generator to drive the circuit right now. Okay, and the scope traces are as usual. So what I'm going to do now is bring up the amplitude until we get some nice oscillations, and I'll use about 12 volts of gate there. 12 volts. Gate is at 5 volts per division, and current viewing resistor is at 2 volts per division. So you can see we have great oscillations, and by doing a frequency determination at 1 microsecond per division, I've determined that the frequency of those oscillations is somewhere in the neighborhood of 4.8 megahertz or so, something like that. Okay, and we know how to do that. All right, and the function generator is chopping, or is modulating, if you will, that signal right now at about 1700 hertz, 1.7 kilohertz. Okay, so that's the frequency of the chopping. All right. Okay, so let's see what the TriField meter says, since we've got oscillations going. And let's take the TriField meter and look around the circuit with it. Look at this. Okay. So that battery loop there is kind of acting as an antenna, radiating. There's some more stuff radiating around here. All of the long wires in the circuit will be acting as radiators. And to prove that it's the circuit doing the radiation, let's see, we should just put that down there. And what I'll do then is turn the oscillations down. Okay, so here we go. Ready? Down, up, down, up. Okay, so we definitely have the circuit radiating in the RF according to the TriField meter, right? But perhaps an even more effective way of demonstrating that it's radiating in the RF is to use a RF receiver, commonly known as a radio. And I've got it tuned to 4.91 megahertz, and I think you can hear, let me just let's turn this down here. Okay, maybe you can hear that that's just a static station there, until I turn up the oscillations. Okay, so we have obviously a strong carrier, and we obviously have that carrier being modulated at an AM frequency. Now, if I wanted to, I even thought about doing this, I may still. This function generator, of course, has a trigger sync input that I can use to trigger the function generator. So if I put a microphone into there and I set the controls properly on the function generator, I can actually trigger the function generator by speaking into the microphone. The Ainslie circuit will broadcast that modulation over the radio, and we will have invented the AM radio transmitter. Let's try it with a different waveform. That's with a triangle ramp. Look familiar? Thank you for watching.